give you an appreciation for the relationship between Ka and the concentration of H+. So let's take a look at a situation like this. We've got HX and it's going to H plus X minus. I think you'd all agree that if I would say that something is more acidic if it was producing more H plus. So if this breaks up more into H plus, then it's going to be more acidic. If we look at the Ka, then the Ka can be measured by looking at the equilibrium expression, and you can see that the Ka and the H plus would be proportionate. So you can say if we have a small Ka, then we're going to have a small amount of H plus, which means that we're talking about a weak acid. If we have a large Ka, then we have a large concentration of H plus. This is at equilibrium, so we're talking about a strong acid. Now I know this is kind of arbitrary, but I would say that if the Ka is less than 10 to the negative 4, we could make that a weak acid, and if it's greater than 10 to the negative 3, then we can make it a strong acid. But this is a very arbitrary dividing line. It's more a continuum than anything else. But it's a good guideline to use. Less than 10 to the negative 4 for weak acids, greater than 10 to the negative 3 for strong acids. There's also a relationship between pKa and pH, as well as Ka and pKa. So let's take a look at what that is. So we know that pKa is equal to the negative log of the Ka. And what we find is that this relationship about weak and strong acids gets reversed when we talk about the negative log of the Ka. Let me give you an example. Let's make the Ka equal to 10 to the negative 50. That's very small, but if we take the pKa of that, that's going to be positive 50. Let me give you another example. Let's give you Ka of 10 to the negative 2. Then the pKa is going to equal 2. So what we can say about a weak and strong acids here, we can say a weak acid has a small Ka but a large pKa. And then if we look at a strong acid, we could say the reverse is true. Strong acid has a large Ka and a small pKa. So what you would say is that the lower the pKa, the stronger the acid is going to be. And I think that's a very good thing to remember. Large Ka, small pKa for strong acids. Now you'll often hear people interchanging pH and pKa when they're talking about strong and weak acids. Just know that there is a relationship between Ka and H+, but they are not the same thing. We can use them in order to define strong acids, but we can't really use them interchangeably because they don't really mean the same thing. Ka is the equilibrium constant. That's a value that contains the concentration of H+, but a bunch of other things as well. Whereas pH is just about the concentration of H+ and nothing else.